Alright, here we are for a little tutorial. I'm going to show you kind of some basics of how to use binary code and to give you kind of an idea of how binary code is transformed into data, in this case numbers, and then we're going to kind of build on that with this lesson. So to start with, I just took 5 little squares of paper and I put some dots on each one. So the one on the far right has 1, the next one to the left has 2, and then we have 4, and then we have 8, and then we have 16. And this is kind of how I learned how to go between binary and regular numbers for values. Obviously, you know, the numbers are doubling as it goes to the left, but also kind of more significantly, if you choose one of these squares and you add up all of the dots of the squares to the right, it's going to be 1 shy. So like here we have 2, you add 1 dot, that's 1 less than 2. Here we have 2 and 1, which is 1 less than 4. And that's what's going to allow us to count using these. So the way I use these squares to show me binary is each of these squares represents a 0 or a 1. Okay, a 0 or a 1. And each of these squares is also worth 1 bit of data. Now if I had 8 squares, you know, I'd have 8 bits, which would be a byte, but I just had 5 pieces of paper handy, so that's what I used. Alright, now the way that we're going to illustrate these is when these are dot side up, that is going to be worth a 1, and if they're face down, they are going to be worth a 0. Alright, so right now the number that I have of these squares, I'm going to say we have no dots showing, and so my binary code is going to be 0, 0, 0, 0, 0. So for 0, 0, 0, 0, 0, in this case, that's going to be equal to the number 0 when I'm converting that. Okay. Now let's say I flip this one on the far right open. I add up all the dots. That's 1 dot, right? And so my binary conversion would be 0, 0, 0, 0, 1, because it's 0, 0, 0, 0. This one is dot side up, so that's 1. Okay. If I move this second one over, then my binary number is going to be 0, 0, 0, 1, 0. Because this one's face down, so it's a 0. That's face down, so it's a 0. That's face down, so it's a 0. That's face up, so it's a 1. And that one's face down, so it's a 0. So 0, 0, 0, 1, 0 in this instance is equal to the number 2. Alright, and so in this case, let's have 2 of these up. What's the binary code going to be? 0, 1, 0, 1, 0. What does 0, 1, 0, 1, 0 equal? That's going to equal 10 because I added up the 8 and the 2. Alright, now in this case here, let's say I wanted to have the number 50. Alright, well if I go and I put all of these face up, alright, I'm not going to be able to get these all to equal 50. So in that case, 5 bits of data isn't enough for me to go that high. So I would have to have more bits in order to make my counting and binary move up that high. Alright, so that's kind of how that works. Now that's converting it one way. Let's say I already have the number and I want to convert back. So then in that case I would start from the left. Okay, and so let's say I wanted to convert the number 15. Alright, so right here, all of those dots, that's 16 dots. 16 is greater than 15, so then I would have to turn that one over and then open up the next one. Okay, now 8 is less than 15. Okay, so we're on to a good start. So now I'm going to flip over the next card. 8 plus 4, we have 12. 12 is less than 15. Good. All right. Now I'm going to flip over the next one. Now we have 14 dots showing. 14 is less than 15, so I keep going. And there we have it, 15. So we have our 8, our 4, our 2, and our 1. And that gives us the value of 15. And in binary, that would be 0, 1, 1, 1, 1. So just to do kind of one more for an example, let's say we want to convert the number 5 into binary. All right, 16 is greater than 5, so that one stays face down. 8 is greater than 5, so that stays face down. 4 is less than 5, okay? 4 plus 2 is 6, that's greater than 5, so the 2 has to stay down. And last but not least, the 1 plus the 4 is 5, which is what we're looking for. So 5 in binary, in this instance of binary, for our example, would be 0, 0, 1, 0, 1. All right, the next thing I want to show you is how we can use binary. This is how we do it with numbers. How can we incorporate letters and symbols in with that? And that's what we're going to look at next. All right, so here we are at the computer, and now we know how binary can work when we're just converting numbers. But how does that work with letters, and how does it work with everything else? Well, here I just have kind of a simplified example of how we could do this. So I have a set of binary values with 8 digits. So here each one of these is made up of 8 bits, so it's a byte of data. And I used the same kind of made up system that I used for my demonstration with the cards with the dots. So I have 0 through 9, and that gets us through how to write any single digit, you know, where then we could string those digits together to make any number that we want to. But what would we do? How could we do that if we wanted to include words if we typed with this? So here's a simplified example of how this would work. All right, so for the value for the 11th value that we have on here, I made that equal to a space. So that's where nothing would be, and that would be 0, 0, 0, 0, 1, 0, 1, 0. So we're going to say that set of numbers, 0, 0, 0, 0, 1, 0, 1, 0, would represent a space where there would be no number or no text. Okay, and then I just continued going down, so like 12, 13, 14, 15, so on. Like 12 is going to be equal to capital A. All right, and then I just went all the way through, and then I just used an exclamation mark and a question mark. Okay, so that is really kind of the basics of this here. I just continued going sequentially up through the higher numbers with the binary numbers, and then I assigned each of them a character from our alphabet or a symbol. All right, so up here we're going to use this now to see the answer for this question. I have the question on, or I have the answer in here in binary code, and it says, what standard binary system do computers in America use? All right, so we have 4 zeros, 1 0, 1 1. All right, so if we look down here, well, that was nice. It was our first one that we had on here, 0 0 0 0, 1 0 1 1. All right, and so that is going to be a capital A. Okay, then we have 0 0 0 1, 1 1 0 1. Okay, 0 0 0 1, 1 1 0 1. For this example, we have this being S. All right, then we have 0 0 0 0, 1 1 0 1. 0 0 0 0 1 0 1 1, and that is going to be our letter I. And actually on here I did make I'm sorry, that is going to be a C. 0000110. Yep, it's going to be a C. My bad. Okay, now I got 0001 0011. Now I'm here to the I. I was looking at the wrong thing above it. My bad. Alright, so on that case, I have an I, and then the last number is equal to the same one before, so that is going to be another one. So the answer is ASCII. ASCII. That's the binary system that our computers in America use. They don't use the same system as this one is. You can Google search ASCII key, and you'll find out. You know, they do have values for all the numbers and for all the symbols, and they have values for whether it's a capital A or a lowercase a, and all the other symbols that are on your keyboard. And that is the system that we use. This one here is just that I have here. This is one that I made up. But the actual computer that you are probably watching this tutorial with is using ASCII binary. And so your computer is faster than we would be able to do it. It's converting all these zeros and ones into letters. Alright, it's even used, yes, for like pixels, which make up the images, and so you figure out, you know, how those can be made, and why with all those tiny pixels an image is going to be much larger than a text file. Okay, so here, that was the example of how we could look at the code and then code it out. ASCII was our answer. And then the other one we have is how would we write the term binary space code with our binary key example. So it's a little easier going this way, right? So to start off, we would, for binary, here's capital B, so that would be 00001100. Okay, and then we would go through and we'd spell binary. And then don't forget the space between binary and code. We do have a value here for that, and then you would spell code. So I'll let you pause this to look at that, and you'll be able to figure it out pretty easily just by finding those values for each of the letters and typing that out. And now you will have seen how to, you know, get the idea of how zeros and ones can actually represent characters, you know, and how we get letters and how we get web pages and how we get text files from just zeros and ones. Alright, the next thing I want to do is I'm going to show you a quick little activity here that we can use to kind of make something kind of neat with binary code. Alright, so what we're going to do now is we're actually going to make a 3D model of a dice, but instead of the die having numbers 1 through 6, it's going to have 1 through 6, but created with binary code. And if you make this and you have access to a 3D printer, you could 3D print it out, you know, and do that. If you have me in class and they turn out well, you know, we can 3D print them in class, and you can have that just for something kind of fun to have. And it's a little bit of practice with some problem solving and using binary code and some other things. So here's 3D Builder, comes free with Windows 10. Alright, and I'm just going to go to a new scene, and I'm going to insert a cube. Alright, went up to insert and cube, and it puts a cube on here. Pretty easy, right? Now there's a lot of different things you can do with the cubes on these. Sometimes you can also insert, and then I click sphere, and if I go down in the bottom here to the scale, and I have the scale locked, and there's a scale tool, you know, and I kind of extend this to make the sphere bigger than the actual cube. And then what I'm going to do is I'm going to use the move tool down here, and I'm going to center this sphere as best I can. It usually kind of locks it into place, and I kind of want it to be in the middle of that cube. Alright, so you have something that looks like this, a sphere that's kind of growing outside of your cube. And then what I'm going to do is I'm going to select the cube, and I'm going to select the sphere. And if I go up at the top here and I go to edit and I select intersect, it is going to cut out the objects where these two things are not overlapping. Okay, so now this is kind of the intersected area of the cube and the sphere. So you could make it just with the cube if you want, but this looks a little cooler, I think. Okay, so here we go. If we look over at our values here for binary code, we're going to have 6 sides to this dice, obviously, right? And so if we look at this, we could put 8 digits of binary on here, but the text is going to be kind of small, you know, so I'm not going to do that. What I'm going to do is I'm going to figure out the minimum amount of bits of information that I could have to make this dice. Okay, so going down at 6, 1, 1, 0, to make a 6, I only need 3 bits of information, right? If we kind of review back to those pieces of paper with the dots, this would be the 4, this would be the 2, then this would be the 1. So my largest number would be 6, which would be 110 in binary. So these dice are only going to contain 3 bits of information for each number to save us some room. Okay, so I have my dice selected, and you could start with whatever number you want. I'm going to start with 1 now that I know. So for 1 I'm going to go 0, 0, 1 because I only need 3 bits of information for all the dice. Okay, so my cube is selected, or my newly created dice shape, rounded cube, whatever you want to call it, is selected. And then I want to go into edit and emboss. Alright, now if I go to emboss, you'll see these letters that are on here, and I have the scale tool selected. I want to make this relatively large so that it can be seen. Alright, and for the text I'm going to type in 001 and I'm going to press enter. Now it doesn't really matter the type of font or the type of typeface you want to use, but I'm going to recommend that you obviously use a serif typeface. And the reason why is because if your text shows upside down, here I can tell that's an upside down 1. I don't think that is 1, 0, 0, right? So you want to choose something that is a serif font that has the little fancy doodads on the ones. Alright, and then what I want to do is when we 3D print these out, this is going to be on the bottom, and I don't want there to be a whole bunch of supports growing in here to build up from the bottom. And if you've 3D printed, you know exactly what I'm talking about. If you've never 3D printed before, just know, like, we have to have something to build the numbers underneath on, and it's easier if the numbers are etched out instead of building out from the dice. Okay, and so I'm going to click this, and I'm going to drag, you know, this little arrow, still using my scale tool. I'm going to drag all the way down until it won't let me go any further. Okay, and so that's there. I'm going to select Emboss. Alright, and now I can look at the dice and I have 0, 0, 0, 1. So there's my 1 on the dice. Alright, now what I want to do is I want to use the rotate tool. I'm going to flip this dice over to the other side. Alright, I'm going to select this dice again. I want to go back up to edit and emboss, and this time I don't want to use 0, 0, 0, 1. I've already used 1. This time I want to use 6. 6 goes on the opposite side of the 1 with the dice. Okay, And on my key over here, that is going to be 110, because 4 plus 2 is 6 plus 0. Alright, remembering back to our cards. So this is going to be 110. And the scale here, I'm dragging this all the way down just to make sure that it goes as far as it can go. And then I'm going to click Emboss. Alright, there we go. So I got my 1 and my 6 done. Okay, now what I'll do is I'll just kind of click and drag and move here. It's a little cumbersome to use this program at first, but if you just kind of click and drag the screen around, if you start to get way off centered with the 3D object and you have it selected, you could go up to View and you can go to Center View, and it'll recenter the object in your window there. So if you started things getting out of control with the panning and the zooming, that's the way how you can get back. Okay, so I have my dice selected here, and now I want to go to Edit and Emboss, and this time I'm going to use the number 2. 2 is going to be 0, 1, 0. Alright, so up here on text, 0, 1, 0. And making sure that I have the scale drug all the way inside. And I got that. Okay. So if 1 was on the opposite side of 6, then on the other side of 2, we're going to have the number 5. So I'm going to go over to the other side of the dice, select it, emboss, and my number for 5 is 101, because 4 plus 0 plus 1 is 5. So I'm going to go 101. I'm going to select Emboss. I didn't select the right number apparently. Let me try that one more time. I just Control Z to undo what I did there. And I'm going to go for 5. There we go. Well, that is a conundrum. Alright, let's try this one more time. One more time on here. Third time's a charm. Let's go to Emboss. 101. Okay, there we go. For some reason my enter wasn't working. Okay, 101. Alright, and there we go. Make sure my other sides are right. Yes, they are. Okay, so now we got our last 2 sides to work on. So I'm going to select Emboss, and this time we need to put 3 on one side. So that is 0, 1, 1. And clicking Emboss. Alright. And then over on this side we have Emboss one last time, and we're going to put in 4, which is going to be 1, 0, 0. Alright, and there we go. We have our dice, 6 sides, but it's in binary. So maybe, you know, if you're going to make some kind of a coding board game, maybe this would be your dice on there, right? So that's kind of a cool little thing you can do. Now when you're finished with this, obviously you can scale this and change it to whatever size. These numbers here are in millimeters, you know, so sometimes what I end up having to do is I'll just go to Google and I'll say 100 millimeters in inches. Alright, and then it'll tell me here how many inches are in, you know, so that would 100 millimeters would be a pretty big dice, right? So if you wanted to, you could probably go like 50 millimeters or 25 if you want to 3D print that out. So you can do that. You can also play around with the different colors and the textures, and then when you're done, you'll save this as, and you're going to save it as the 3D builder file, and then you're also going to save it as a STL, because typically if you are going to 3D print these, you're going to need it as an STL code so that it can be converted into G code. But at least this way you made a 3D model. We found some creative ways to use binary code and how to convert it to numbers into letters and all that type of thing. So here it is. Hopefully you learned a lot. You can, for something else, you can maybe try to make a dice that has more sides, like with the many different sided dice that they have out there, and make it binary with that as well, or kind of whatever creative ideas you can get to make those things. But hopefully the video was helpful, and now you are a little better at understanding binary code and how it can be transferred into number and letter data. Thanks for watching.